Hello there and welcome to a brand new lesson. This is Hard Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at the AC method of factoring ax² plus bx plus c. By the end of this lesson, you should understand when to use the AC method. You should be able to apply the AC method to factor quadratic trinomials with a not equal to 1. You should also be able to use the AC method to solve quadratic equation by factorizing. And you should be able to recognize prime quadratic that cannot be factored using integers. And finally, you should be able to apply all that we have learned to real-world problems. Now, as the lesson proceeds, we'll be looking at, I'll be making mention of these vocabularies, and I want to quickly go through before we proceed. For the AC method, we'll talk about it in our next slide. When we talk of the factor by grouping, it is the method where terms are grouped in pairs and common factors are factorized out from each group. Most of the times, we use the factor by grouping when we have even number of terms. So the AC method applies this when it splits the number of terms from odd, which is 3, to 4 terms. When we talk of a non-monic quadratic, it is simply a quadratic whose leading coefficient, that is the a, is not 1. So if you have 3x², we have 3 here, which is the coefficient of x². Hence, this is not a monic quadratic. But if it's a monic quadratic, then our coefficient is 1. When we talk of a prime quadratic, it is a quadratic that cannot be factorized over integers. You get it? So for something like this, we realize that we can't use the AC method to factorize. So without much ado, let's quickly go straight into the lesson to enhance our understanding. So with all that said, let's look at the steps involved in the AC method. We know the general form of a quadratic equation is ax² plus bx and then plus c. So anytime you have a quadratic of this form, you take note of the value of your a, the value of your b, the value of your c. Now the AC method works best if the value of a is greater than 1. Nevertheless, if it is 1, it still works. So if you understand this, you can solve for when it is 1 or more. So the first thing you do is to multiply your a by c. So whatever value you have here as a, multiply it by c. You see? And if we multiply a by c, let's just call it m, the multiple we'll get. Now, you'd rewrite m in terms of factor pairs. You see? So you look for factor pairs of m. That is to say, what number times what other number multiplies to give us m. You see? But then, when we add them, we are going to get what? B. You see, very soon we'll be looking at examples that would explore all these, and then you'd get to know how practical it is. So we said multiply the value of a by the c to give you m. Then look for factor pairs of m, that when you add, you get your b. If you're able to get these two numbers, that is your q and then p, what you then do is you rewrite this whole thing you have over here in terms of what? These new factors we've gotten. That is to say, instead of our bx, we know we have been able to rewrite b as q plus p. So instead of the b here, we'll rewrite it as q plus p x. You see, and with that, the x distributes over these two, so that we have our q x then plus p x. You see, so we substitute all of this just for the b, so that in turn it becomes ax² plus, instead of our bx, we have q x and then plus p x plus our c. So the factoring method, or let me say the AC method, is simply trying to rewrite these terms, all we have over here, to give you even number of terms. You see, we had 1, 2, 3. There were 3 terms, but we need them as 4 terms so that we can then use the method of grouping to simply factorize. That is all. If you're able to rewrite it this way, the method of grouping takes over and you'll be able to factorize. So with this understanding, let's solve some questions. If you don't understand this explanation, just relax. I'm sure by looking at the examples, you might be able to get on track. So looking at our first question, it says you have to factor completely using the AC method 2x squared plus 7x plus 3. So we have 2x squared plus a 7x and then plus 3. We want to use the AC method. Now the first thing we need to do is to take note of our A, B, and then C. So our A is equal to 2, our B is equal to 7, and then the C is 3. That is A, B, and then C. So with that, we need to find our AC. That is multiply A by C, and that is 2 times 3. This is our A, and we are multiplying it by the value of C. That simply gives us 6. Now this 6 that you have, what you are going to do is you are looking for factor pairs of 6. When we talk of factor pairs of 6, we simply mean numbers that when you multiply, you get 6. And at the same time, if you add those numbers, they should give you 7. 7 is the B. You see? So we said this is simply our M from our instructions. So factors of M, factor pairs to be specific, that when you add, you get the B. Any factor that comes to mind, you can write it. So if I have 2 in my mind, I'll write my 2. 2 times what gives me 6? 2 times 3. So for 2 times 3, it currently gives me 6. But if I add 2 to 3, do I get 7? No. 2 plus 3 gives me 5, but we want 7. Does any set of factors come in your head? You can try 2 times 3. You can try 3 times 2. 3 times 2 is even the same as what we have here. So you think again of any other factors. We have 6 times 1, or 1 times 6. It is the same thing. 1 times 6 gives us 6, all right. But if we add 1 to 6, do we get 7 as we expect? Yes. So that is to say, for the factor pairs, there would even be no need to look for any other again, but then we would settle on these we have here. So that instead of our 2x squared plus 7x plus 3, we are going to rewrite the 7 in terms of 1 and then 6. That is to say, we have 2x squared. Then instead of the 7, we would write plus 1x and then plus 6x plus 3. So you see, instead of the 7 now, what have we done? We have rewritten in terms of what? 6 and then 1. And you know, if you add your 6 to your 1, you are going to get 7. That is just what we've done. Now we have 4 terms. We can then factorize by grouping. So the factorize by grouping simply says we should group them in 2s. So these 2 would be in their own group, and then these 2 would also be in their own group. So this is what we have here. I have grouped them into 2. We ask ourselves, what does 2x squared and then x have in common? You know, 1x is the same as x. So if anytime you are working and you see the 1, you can choose not to write it. So 2x squared and then x. First of all, in terms of the numbers, what is their common factor? It is 1. Then for the variables, there's x squared and then there's x here. What do they have in common? They have an x in common, so we write that x. Then x times what gives us a 2x squared? X times 2x. X times what gives us an x? That is a 1. You see, so if you were to revert it, you have x times 2x giving you your 2x squared, then x times 1 giving you your x. Then for this as well, we have positive 6 and then positive 3. For the numbers, what do they have in common? Their common factor is a positive 3. You see, and then what of the variables? Do they have any variable in common? This doesn't have the variable, but this has the variable. So they don't have any common variable. Now 3 times what gives us 6? It is 2. But there's an x there, so 3 times 2x should give us 6x. 3 times what number gives us 3? That is a positive 1. So with that, you see what has happened. We have this bracket and this bracket looking alike. You see, so this bracket here looks the same as this bracket we have over here. So what we do is, what we have as the coefficient of the bracket will be written in one bracket. So we have x plus 3, that is this coefficient here, and then this coefficient here. We have written them together. So this x plus this 3, giving us x plus 3. Then into the other bracket, we have 2x plus 1. And that is it for the factorization. So it simply implies that our 2x squared plus 7x plus 3, when factorized, gives us what? An x plus 3, then 2x plus 1. You can always choose to confirm to check if your answer is correct. So this is our solution, and this is our answer. I do hope the understanding is coming bit by bit. Let's solve some few more questions to enhance our understanding. So for our next question we have here, it says you have to factor completely 3x squared plus 10x plus 8. So we have 3x squared and then plus a 10x plus 8. So by observing, we know our a is equal to 3, our b is equal to 10, and our c is equal to 8. That is comparing it to the general formula. So with that, we have our AC. So the product of A and then C becomes 3 times 8. And 3 times 8 gives us a 24. You see? Now we need to find factor pairs of 24. That when we add, we will get the value of B. So for 24, what are some of the factor pairs you can think of? You have 12 times 2. So 12 times 2 gives us a 24, doesn't it? But if we add 12 to 2, do we get 10? No. 12 plus 2 gives us a 14. So we can't use 12 and then 2. Let's think of other factor pairs. So we have 6 times 4. 6 times 4 gives us a 24, right? So 6 and then 4. If we add 6 to 4, do we get 10? Yes, we do. So 6 and then 4 gives us 10. Now, it is important to take note that you don't only rely on your positive factors. Because if you have to take 24, you have factors such as negative 6 and then negative 4. Negative 6 times negative 4 gives us a negative 10. So in view of this, if this was a negative 10, we wouldn't be relying on 6 and 4, but rather negative 6 and negative 4. You see, so it is important to be open-minded, and then you don't only focus on the positive integers, but then also on the negative integers. Now, since we have the factor pairs we are going to use, we use that to split out the thing. So that becomes a 3x squared, then plus, instead of 10x, we are rewriting it as 6x plus 4x, then plus 8. We can now use the method of grouping to do our factorization. So with the method of grouping, we just group them into twos. I'll have this here and then this as well. So what does 6x and then 3x have in common? We first of all focus on the numbers. What is their common factor? Their common factor is 3. And then when we come to the variables, there is x here and then there is also x squared here. Their common factor is always the variable with the lowest power. So that is x. So 3x times what gives us 3x squared? It is simply times an x. If you don't know that offhand, after getting your common factor, you can always do what? Divide. Talking of division, I mean you have 3x squared divided by your common factor you have here, which is 3x. The 3 cancels out the 3, and this x reduces this x by 1, giving you what? Your x. So the same can be said about this. We have 6x and then we are dividing by 3x, which is our common factor over here. 3 divides 3 to give us 2. And then this x cancels out to this x. So we have plus 2 over here. You see, math is very, very dynamic. There are so many ways you can use. The most important thing is you understand the concept and then you can work it. That is why I spend most of the time on my lessons explaining the concept for you to understand. If you get the concept right, the solutions are just very simple, as you are seeing. So for what we have here, we have 4x and then 8. In terms of the numbers, the common factor of 4 and 8 is simply what? A positive 4. Then 4 times what gives us 4x? We have our x. 4 times what gives us 8? That is a positive 2. So just as we have done in the previous one, the coefficients will be rewritten in a nice bracket. So that we have 3x, then plus 4. That is the 3x here, and then our positive 4. Then into bracket x plus 2. This is what we have. Then that is just it. We have been able to factorize it. So with that, we can simply say it implies that what we have here, which is 3x squared plus 10x plus 8, when factorized, gives us a 3x plus 4 and then an x plus 2. Very simple. Now, if we know how to factorize, then we would have to be able to find the roots of quadratic equations. You see, so for an equation, there's an equal sign. And if there's an equal sign, you would have to factorize and solve. You factorize and solve. For all we have done so far, they are just expressions. This one has no equal to whatever. This also has no equal to whatever it is. So let's look at one that would have an equal sign and then see how we proceed after being able to factorize. So for this particular question, it says solve by factorizing or factoring. 4x squared minus 11x minus 3 is equal to 0. This time around we have is equal to 0. It is an equation, not just an expression. So we have 4x squared, then minus 11x, then minus 3 is equal to what? 0. We use the method of factorization to factorize this expression and equate it to 0. Once again, we have our a being equal to 4, our b being equal to negative 11, and our c equals negative 3. If you have to multiply A by C, you are going to get 4 times negative 3. 4 times negative 3 gives us a negative 12. We now look for the factor pairs of negative 12, which when we add, we should get a negative 11. So what are some of the factor pairs of negative 12? You have negative 4 times 3. So negative 4 times 3 gives us a negative 12. But then if we add, we don't get negative 11. We have 6. We can also say negative 3 times 4. That would have also given us, that would have also not given us negative 12. You see, so you try so many. The thing is, if you keep solving this type of equation, you'd be able to easily determine the factor pairs, because it just comes, because you have understood and then you always know what to expect. For negative 12, for instance, I would say if I pick a negative 12 times 1, negative 12 times 1 gives us negative 12. And if you have to add negative 12 to 1, what do we get? We get a negative 11. So we can easily use this over here. You see, so now we have 4x squared. Then instead of negative 11, we are going to rewrite it as what? Negative 12x, then plus 1x. So 1x can be written as plus x. And then minus 3 is equal to 0. There are 4 terms now, so we can factorize by grouping. So the first two group together, and then the second two also grouped together. So with that, for the numbers here, the common factor is simply 4. Then for the variables, we always take the lowest power, so 4x. 4x times what gives us 4x squared. As I said, you can simply divide to check what you have remaining. 4x times x gives us 4x squared. Then 4x times what gives us a negative 12x, that is a negative 3. We have, for this as well, we have 1 and then negative 3. What are the common factors of 1 and then negative 3? That is a negative, that is a positive 1. Now positive 1 times what gives us x, it is simply an x. Then positive 1 times what gives us negative 3, it is simply a negative 3. That is equal to 0. So after this, we do our factorization again. That is the coefficients be in one bracket. So 4x plus 1. And then since these are the same, we just write them as well. X minus 3 is equal to 0. So this is where the AC method ends. But we have to solve for x. So to solve for x, we then equate both brackets to 0. By both bracket, I simply mean we are going to equate 4x plus 1 to 0. You see, then you also equate x minus 3 equals 0. Then you solve for your values of x. So x minus 3 should also be equal to 0. So with that, we then take them one after the other and solve. Let's start with 4x plus 1 equals 0. 4x plus 1 is equal to 0. Making x the subject, we have 4x being equal to negative 1. And our x is simply negative 1 over 4. For this other one, we have x minus 3 is equal to 0. Making x the subject, we have our x being equal to 3. And that is all. So we can say, therefore, our x is equal to what? 3, or x is equal to negative 1 over 4. As simple as that. So that solves this equation. You take note that for all that we've done, if you are factorizing, you don't need to equate anything to 0 because it is not even an equation. It is just an expression. But for solving, because of the equal to 0, after factorizing this, you'd equate both brackets to 0. And then you find for the value of x. We look at one last word problem just to apply all that we've studied, in this session so far. Our last question here, it says, a rectangular garden has length 3 meters more than twice its width. The area of the garden is 65 meters squared. Find the dimensions of the garden. So let's try and then get a visual representation of what this is. First of all, it says the length is 3 meters more than twice the width. So if this here is our width, and then this is our length. Now, twice the width is simply what? 2w. But this length we are talking about, they are saying it is 3 meters more. So 3 meters more than twice the width. This is what it means. You see? And it says the area of the garden is 65 meters squared. So this whole area is 65 meters squared. Hence, we have to find the dimensions of the garden. So we want this W so that it will help us get the length as well. So how do we go about this? You need to know the formula for area, and then from there, you can also do the needful. We know the area of a rectangle is given as what? The length times the width. And in this case, our width is W, and then our length is 3 plus 2W. So we are going to get 3 plus 2W, then times the width, which is W. If you are to open up, we have 3W plus 2W squared. And mind you, we had our area being what? 65 meters squared. So we have 65 here. So with this, we would have to write it in the standard form. So that we have a 2W squared, that is from here, then plus 3W, and the 65 is moving to the right hand side, so that it becomes a negative 65 is equal to 0. So we have to write it in this form so that we can easily solve. So with this here becomes the main equation we want to solve for. If you're able to solve for this and then get your W, then you can proceed from there. So let's take our equation, and then on the next page, we have 2 times negative 65. So we have 2 times negative 65. And that gives us a 130. A negative 130 for that matter. Now we want the factor pairs of negative 130. That when we add together, we'll get this 3 we have here. You see, so we want factor pairs that when we add, gives us the 3. What are these factor pairs? So looking at the factor pairs of negative 130, we have, let's say, a 13 times a negative 10. You know, 13 times negative 10 gives us negative 130. If we add it as well, we'll get a 3. So we use these two to open up, so that instead of the 2W squared plus 3W minus 65, which is equal to 0, we will rewrite it as 2W squared. Then instead of the 3W, we would have a positive 13W minus 10W, then minus 65 is equal to 0. So with this, there are 4 terms. So we group them into 2's. And then we can now solve them using the method of grouping. So with that, what is the common factor of 2W squared and then 13W? For the numbers, they are co-prime. So there's nothing that we can do about it. But for the W, we are writing the lowest power, which is W. Then into brackets, w times what gives us 2w? That is a 2w. I mean, w times what gives us a 2w squared. So as I said, if you don't know it offhand, you can always choose to divide. Then w times what gives us a 13w. That is a positive 13. Now, from all that we've done, you realize that anytime we get this first bracket, it is the same thing that repeats, provided you are doing it well. So that is to tell you that we are expecting a 2w plus 13 as well over here. But if that is what we are expecting here, 2w times what gives us a negative 10. That is a negative 5. You see, this is the very simple way you can solve it as well. So negative 5 times 2w gives us a negative 10. Then negative 5 times 13 gives us a negative 65. With that, we need to factorize this and then this out. So that we have w minus 5 in one bracket. Then on the other hand, we have what? 2w plus 13, which is equal to 0. Solving for our w's, we have w minus 5 being equal to a 0, and our w is equal to 5. Then equating this as well to 0, we have 2w plus 13 is equal to 0. 2w being equal to negative 13. And then our w, which is equal to negative 13 over 2. Now, we would always reject the negative because we are talking of width here. Width are absolute values. We don't work in negative. So we are going to reject this negative answer and then stick only to this. It simply implies that our w is equal to what? 5 meters. But remember, we said the length is equal to 2 times of the width plus 3. So we would need to solve for that. So that we say our length is then equal to 2 of w, which is now 5. So of 5, then plus 3. Evaluating further, we have 2 times 10, which gives us 2 times 5, which gives us a 10, then plus 3. Hence, we have 13 as the length. So we can form our conclusion and say, therefore, the width is 5 meters, and then the length is equal to what? 13 meters. As simple as that. So that brings us to the end of this lesson. I do hope you were able to comprehend all that we did. As usual, I'll leave with some exercises so that you try on your own to test your understanding. So here you have 5 questions you can try on your own just to test your understanding. I do hope this lesson was helpful. If there's any issue of concern, you can always let me know at the comment section. If this is your first time on the channel and you think it will be of help to you, you can choose to subscribe if you so do, so that anytime I release a video, you'll be notified as well. See you in our next lesson, and bye for now. Do stay safe.